Alright, so our next page, we're still dealing with equations of a line, and we want to emphasize that slopes of parallel lines are the same. Right? And so maybe I could take a line here. Let's do a line where our y-intercept is 3, and our slope is down to over 3. Let's do that one, right? So the line 1, or y1, is going to equal to, our slope is down 2 over 3, so negative 2 over 3. Rise is negative 2 over 3 of a run of 3. X plus our y-intercept is positive 3, plus 3, right? And so let me go ahead and draw this line. And then if we have another line, let's say y2 is going to equal to, and let's do negative 2 as our y-intercept, but with the same slope, right? The same slope of negative 2 over 3. So that means rise negative 2 down here, and then run positive 3 over to here. Right? I'll draw my line. And you can see that they're parallel, right? And if I go ahead and write this equation, it'd be the same slope. And then the y-intercept would be negative 2, like that. So if we have the same slope, then that means these two lines never touch each other, and they are parallel. Okay, so slopes of perpendicular lines are negative reciprocals. Negative reciprocals. And what does that mean? That means if the slope is equal to a over b, then the negative reciprocal would be negative b over a. Okay, so yeah, so maybe I could show you here. Let's do a y-intercept of negative 1, and then let's do a slope of up 2 over 2. So let's do that. Right. Okay, so our y1 is going to equal to negative 1. So slope of negative 1, right? So down 1 over 1, down 1 over 1. So that's the slope of negative x, right? Slope is negative 1. And then our y-intercept is also negative 1. Okay. And so for this line, our slope m is equal to negative 1 over 1. Okay. So then what would be the line perpendicular to this? It would be where the slope is the negative reciprocal, right? So we're flipping the numerator and the denominator, and we're also changing the sign. So our y2 is going to equal to positive 1, or x, minus, let's do the same y-intercept at negative 1, right? So what did we do? The slope here is positive 1 over 1. Right, I took the numerator and denominator, I flipped them, and then I've changed the sign also as well. Right, so over here I'm taking the numerator and denominator, I'm flipping them, and I'm changing the sign. So this is what we get. And then if we graph it, you can see we have negative 1 as our y-intercept, and then our slope is 1 over 1, 1 over 1, 1 over 1, right to there. Right to there. And then if I graph it, you can see that they are perpendicular. Okay. Now horizontal and vertical lines. Well, horizontal lines, it's where you have an equation that says x is equal to some constant like 2. Or a vertical line is where you have y is equal to some constant like 5. Right? We saw an example of this in the previous problem set, but maybe I could still say it here. So if we do this, and let's say y is 5 right here. This is our y-axis and our x-axis. Oh, I think I got this flipped around actually. A horizontal line is y is equal to 5. I'm sorry. So it goes like that. And a vertical line is x is equal to 2. Okay. So if we have y is equal to 5, that's a horizontal line. So why? Because this means that our y-intercept is 5. Our y-intercept is 5. Our b is 5. B is equal to 5, and our slope m is equal to 0 over 1, right? There is no slope. So this is our y-intercept, and then we're going to graph our rise is 0, our run is 1, rise 0, run is 1, rise 0, run is 1, over and over again. And if we connect those dots, we get a horizontal line, right? And then if x is equal to 2, we get the same thing, just a little different. So let's do 1, 2. So if x is equal to 2, then that means our y-intercept is 2. I'm sorry, our y-intercept is 0. And our... how does this work out? Give me a second. So we have 0 is equal to negative x plus 2. Well, yeah, I'm not sure exactly how to explain this. I'm at a loss, but to continue the video, if you do have something, an equation that says x is equal to 2, then what we have is a vertical line passing through the 2 on the x. So it goes like that. Okay, where this is our y-axis, and this is our x-axis, and that's our 2 value on the x. So anyhow, so let's go ahead and write this example here. Write an equation of the line through these 2 points in slope-intercept form. Well, how do we do that? Well, this is going to be our x1 and our y1, our x2 and our y2. And we'll use our slope form to our slope equation to calculate the slope first. So m is going to equal to 6 minus 6 over 5 minus 2. I'm sorry, 5 minus a negative 2. So then that's 6 minus 6 is 0 in the numerator, and then the 5 minus a negative, this turns positive, so it becomes over 7. And the slope, you could see, is 0. Right? Or 0 over 1, or 0 over 5, or 0 over 7. Right? It doesn't matter what the denominator is if the numerator is 0. So now that we have the slope, what we can do is take a slope and the point that the line goes through. It doesn't matter which one you choose, because the line goes through both of the points. And then we're going to use point-slope form to write our equation. Right? We're trying to get it into slope-intercept form, but first we need to get it into point-slope form, and then we can kick it into slope-intercept form. Right? So the way it goes is like this. We go y minus, let's use this point here, minus 6 is equal to 0. X slope is times x minus 5. It's like that. Well, 0 times any value is going to be equal to 0, so what we're going to end up with is y minus 6 is equal to 0. We'll add 6 to both sides, and we'll get y is equal to 6. Right? So this is the equation of line in slope-intercept form. Right? Here our slope is 0, and our b is 6. So m is equal to 0, and our b is equal to 6. All right, so how do we graph this? Well, we come over to here, and we go 1, 2, 3, 4, 5, 6. All right, so again, I'm going to make each step 2 units. So it's going to be 2, 4, 6. And then my slope is 0, so that means I just go on a horizontal line at y is equal to 6. Right, so that's what we're doing. If you're ever asked to write an equation of a line, you're given 2 points, and they tell you to write it in slope-intercept form. You first put it in, you first find the slope using the slope formula. Then you put it into point-slope form, and then you do the math. Right, you distribute out this number here, the slope. Then you add the 6 to both sides, right? And then suddenly you have it in slope-intercept form. And so that's what we're going to be doing in this extra practice, and I'll be showing the answers to them in the next video.